Breathing and settlement on Mars. Feasibility for humanity. If you want to safeguard and nurture life on Mars, it's not just about warming the planet. It's also about finding a way to shield it from harmful ultraviolet radiation emitted by the sun. Mars's atmosphere is predominantly composed of approximately 95% carbon dioxide, with a small amount of nitrogen and argon, along with traces of various other gases. Among these, CO2 is plentiful on Mars, making it one of the most abundant resources alongside Martian soil. What makes CO2 particularly valuable is its oxygen content. If we can extract this oxygen from CO2, could we utilize it for practical purposes? In today's episode, we delve into this question. Make sure to stay tuned until the end of the video, and don't forget to subscribe to the channel and give this video a thumbs up. The air on Mars is mostly carbon dioxide, which isn't good for breathing. To live there, we need to figure out how to stay alive. Some people think we could use the systems on the International Space Station, ISS, to help us on Mars, but there's a problem. If the machine that makes oxygen breaks, we could run out of air and suffocate. If the machine that cleans our water stops working, we could die of thirst. Let's look at the ISS more practically. It's been up and running for over 20 years, and it's got systems to make sure we have enough air to breathe. One system, called the Water Reclamation System, WRS, collects and cleans water from different sources like pee and water vapor, so it's safe to drink. Some of this cleaned water is used to make oxygen through a process called electrolysis, which uses electricity to split water into oxygen and hydrogen. Oxygen is what we breathe, but handling the hydrogen, which can catch fire, is tricky. So, another system called the Sabatier system is used to mix extra hydrogen with carbon dioxide waste to make water, methane, and heat. The water goes back into the system, and the heat helps keep things comfortable. Right now, we don't have a good use for the methane, so we just let it go out into space. In space, we focus on saving important stuff like hydrogen, oxygen, and carbon instead of whole things like water and cooking gas. But we still have a problem because these things slowly run out over time, which could be dangerous for keeping people alive. To deal with this, there's an idea called Level 2.1. It's all about bringing what we need, keeping it clean, and planning how to get more of the heavy stuff. But even with this plan, we'll still hit roadblocks, so we need to keep exploring and finding solutions as we travel through space. On the International Space Station, ISS, the Russians made special machines that use powdered sodium chlorate and iron in containers. When these containers get really hot, the sodium chlorate changes into sodium chloride and oxygen gas. But back in 1997, there was a problem with one of these containers on Russia's Mir space station. It caught on fire and made it hard to get to one of the escape vehicles for a little while. Luckily, the crew put out the fire without hurting the station's main part. Most space crews use special oxygen tanks to fix small leaks, especially during long missions that aren't super urgent. But these tanks need to be refilled from Earth, so they can't work by themselves for too long. This makes us wonder, how can we make air to breathe on Mars with what we have there? Level 3 thinking focuses on sustainable living on Mars, where finding ice for water is essential. MOXIE, a technology, converts carbon dioxide into oxygen, but careful temperature control is crucial to avoid damaging other rover instruments. Despite challenges, MOXIE has produced enough oxygen to sustain a small dog for 10 hours, although intermittently. Future efforts require a larger power source for sustained oxygen production. The difficulty of breaking down CO2 poses a challenge, as current systems are inefficient and require specialized equipment. However, advancements in low-temperature plasmas offer promising alternatives for oxygen production on Mars. In a CO2 molecule, movements of the bonds between carbon and oxygen atoms can lead to its natural breakdown. By passing electricity through CO2 gas, energy is added to these movements, creating a low-temperature plasma where molecules become charged. When many CO2 molecules with different movements interact, energy is transferred to the most active molecule, causing it to break apart, yielding carbon monoxide and atomic oxygen. Scientists are exploring this process to combat climate change, which is challenging on Earth due to high temperatures and pressures, but more feasible on Mars due to its lower pressure and colder conditions. Currently in experimental stages, this technology could be crucial for future space travel, enabling the generation of oxygen and fuel from Martian resources, facilitating human colonization efforts. Thank you for watching this video. Don't forget to like and subscribe the channel. Goodbye.